All right, new chapter. In chapter 2, we're finally going to get to solve for x, right? We haven't done a whole lot with equations. In chapter 1, we really focused on simplifying expressions. But now we get equations that have an equal sign in them. Solving an equation means finding the value that makes the equation true. That's all we're trying to do, is make a relationship, both sides of the equation, balance. We write the solution set in curly brackets. So remember, set, that word for us means curly brackets. Hopefully we've been getting better at drawing those. If you're having trouble drawing your curly brackets, like I do, I have lots of practice. But one trick is you can make like a parenthesis, then a little triangle, then a parenthesis. So parenthesis, little triangle, parenthesis. That tends to look pretty good. I want better than just that. That's not a curly bracket, y'all. So do something that looks a little nicer than just random line being drawn there. I don't even want that on my paper. All right, so let's try. It says find the missing value. We're really starting out with, I hope, easy problems for us. But some of us haven't taken algebra before, possibly, so we want to start at the beginning. But the other thing I'm going to be focusing on is really showing work, writing it out well, checking your solution. So in this set of video notes, that's really what I'm grading. I hope that if I just asked you what plus 3 makes 7, you could probably figure out those 4, right? It might take a little thought, but if you're looking at, well, what plus 3 makes 7, that the answer is 4. Great. I'm not interested in the answer for this set of video notes. I'm interested in how you're writing it or how you're solving it. So the way we do this, we're actually going to do PEMDAS backwards because we're going to try to get x by itself. So we're going to undo this addition. So I'm going to undo add with subtract. We always do the opposite thing. So if it's x plus 3, the opposite of adding 3 is subtracting 3. Now, one thing I want to make sure we know is when I say both sides of an equation, that's the equal sign. So the equals divides the equation into two sides. You could put a line there, you don't have to. But that's what we mean when I say do the same thing to both sides of the equals. So then what we're left with on the left is just x, because positive 3 and negative 3 go to 0, equals 7 minus 3 is 4. So that's the basic, like how to solve an equation. So now we're going to check our solution, because when we get to harder problems, we're going to want to know if we got it right. So to check, that just means plug it into the original equation. Where there's an x, I replace it with a 4. 4 plus 3 equals 7. Yep, checks. So then we're going to write out the solution set. So what that means is putting the number 4 in curly brackets. In a solution set, we do not put the x. So it is not correct to just put curly brackets up here. Again, I don't even want them there. Like, that doesn't work. X should not be equal to the set. It shouldn't, it's sort of like drawing a box around your answer. Some people think of that. It's a very formal way to say that these are all the x's that make this equation true. That's what a solution set is. All right, so I know this is a very formal process, but we're in college now, so things are a little different than they may have been in high school. Let's try the second one. I'm trying to get x alone. So let's write that the term solve means get x or whatever variable they're calling it alone on one side of the equals. On one side of the equals. Turns out it doesn't matter whether it's the left or the right side. So I can leave it how it is. If that bothers you though, it's totally fine to write it as x plus 1 equals 6. Some people really like to have the x on the left, and that's fine because the equal sign can be reversed. But I'm going to go with it how it was here. I have to undo adding. So the opposite of adding is subtracting. So I'm going to subtract 1 from both sides. And again, both sides means this equals. So on the right, +1 - 1 goes to 0. And on the left, 6 - 1 is 5. So the answer is that x equals 5. Again, if it works better for you to think of the x coming first, you can always reverse it like that. Either way, we should still check, because checking's easy. All we do is plug in the 5 here. 6 equals 5 + 1. Oh, that's true. So it checks out. So that means the solution is the number 5. All right, so I know we're going through lots of detail on problems that you may think are like super easy, but it's how we're writing them that we want to get in this habit of writing them while it's easy problems, so that when we get to hard problems, we know what to do. All right, so let's try it. Solve the following equations showing your operation, state the solution set. Again, that means our curly brackets, and check your answer. Let's do it. So opposite operations, the opposite of subtracting is adding, because I'm trying to get x alone on the left side. Anytime we see that solve, that means get x alone. And if you want to draw the line for the equals, that works. So -4 + 4, that goes to 0. So I'm left with just x on the left. 1 + 4 makes 5 on the right. So before I write the solution set, let's check to see if we actually did it right. I plug in 5 in for x. 5 - 4 equals 1. That checks out. That's true. So then the solution set is the number 5 in curly brackets. Nice. Hopefully that's going smoother. We're making sense. Let's try this one. This one's a little different. They could have written this as 6 equals x - 4. So adding a -4 is the same as subtracting 4. Either way, the way to undo that -4 is with a +4 on both sides of that equals. So -4, +4, that goes to 0 and cancels. So we're just left with x on the right. 6 + 4 makes 10. So let's check. 6. Oh, and sometimes you might see a question mark over the equals. It's just saying, like, does it equal? It's like a question, like, does 6 equal -4 + 10? Yes, it does. So it works out. So our answer is the solution of 10 in curly brackets. All right. One thing you might want to do is simplify your equation before solving, right? That might be combining like terms. In this case, it's seeing a double negative. Right away, I'm going to write that as z + 2 equals -7. I don't want to leave it as minus a negative. So now that we have the equation simplified, now I know to undo addition with subtraction. So I'm going to subtract 2 from both sides. So it cancels on the left. And we're left with z equals -7 - 2 makes -9. So if I check, I'm going to just check in my simplified form. -9 + 2 does equal -7. Yep. So the solution set is -9. Nice. All right. Last one. Oh, and it's got fractions, but we can handle fractions, right? We're not going to be scared of fractions. We're not going to avoid them. We're going to just handle them with care, and then it'll be fine. Same rule applies. I just need to undo subtraction. So the opposite of that subtraction is to add 3/4 to both sides. So I'm not going to freak out that there's a fraction. I'm just going to undo subtraction with addition. All right. So on the right side, I'm left with x. But on the left, I'm going to write as subtraction because of that negative. So it's 3/4 minus 1/2. Right? Because positive 3/4 minus or negative 1/2 is the same as subtraction. All right, we got to find a least common denominator. The LCD, well, I could make the 2 into a 4 if I just multiply it by 2 over 2. So in that case, that would be 2 over 4. And 2 over 4 is definitely the same as 1/2. All right, you could have used a denominator of 8, like 4 times 2 is 8, but that wouldn't be the least common denominator. It would make more work for you because you would have to reduce your fraction at the end. So I'm going to use 3/4 minus 2/4 equals x. Once I have a common denominator, the denominator is 4, and the top is just 3 minus 2, which is 1. So x is 1/4. Let's check. Checking just means plugging in. So we want to know, does negative 1/2, does that equal 1/4 minus 3/4? The nice thing is this is already common denominator over here. So that would be negative 2 over 4. How does that reduce? Negative 2 over 4. I would need to divide by 2, and then I would get negative 1 over 2. Oh, look, that's the same as what we were trying to check. So it worked. And that means the solution set is the number 1/4.